Previously on Audio Tom.
This is a dual 714Q. 45 speed did not work on this turntable. So I guess he went in there with a pair of pliers and just bent them up. Okay, capacitors are all replaced. And switch it from 33 to 45. Nothing. Absolutely no improvement whatsoever.
All right, so I've checked the voltages. Everything tests out okay there. So now we got to look at the schematic and start digging into it and try to trace out where the problem lies. And you want to start at the source of the problem, which in our case is the switch for choosing 33 and 45. Now, I've cleaned everything. Everything tests out good mechanically. So now let's look at the schematic and try to figure out how things are working here. So if you follow my pointer, this here is a switch for choosing 33 or 45. This is the switch for turning off or on the pitch control. And this switch here is actually in the dial control where this 33 and 45 switch is located, and that's basically just the switch which is choosing either 33 or 45 potentiometer. And if we follow up where B is, this is like the input of that whole circuit, and follow up here to there to pin 1, Y. That is 5 volts. That's our 5 volt rails. The 5 volt rails comes down, feeds a lot of stuff, but also comes down here, branches off, and feeds this entire circuit that we're looking at right now. So 5 volts comes in, and it goes through these 2 potentiometers and back up into the control board. 5 volts comes around here, goes into this switch here, to turn the potentiometers or the pitch control off and on. And then 5 volts comes over here to the switch, which is either closed or open, as its 2 choices, and would either feed 5 volts up into here for choosing 33 or 45. And there's some lines down here on my model, the 714. We can ignore these. These go up to the front panel display, which my model does not have. So in my case, I can completely ignore those. So when the switch is open or closed, what I found is I have 5 volts on the other side of the switch. Now if we follow this line around here to here where it jumpers across to the next board, which is looking on the turntables off to the left, it says for 33 equals 5 volts. For 45 equals 0 volts. But when we switch this, turn the switch open or closed, we always have 5 volts on this line. So we got to find out where that 5 volts is coming from, because that's what's telling it to stay in 33. So if we follow this line, it comes across here, jumps over to that other board, which is the 9100 board, and then goes into different components, which I'll cover as needed. But first we're going to go off and look off to the left here into this board, and you hit a resistor and it comes up. And it hits an array of diodes up here, and those diodes go into some ICs, etc. Or possibly an IC. No, there's 3 different ICs. So we want to find out where this voltage is coming from. So first step I am going to do is I am going to remove this resistor here, and then see if with this circuit, with this now being open and disconnected from these diodes up here, do I still have 5 volts? If I do, then if I do not have 5 volts, then I know it's leaking from up in this array, and I got to start hunting through that. So let's do that now.
Here's that control board, and it's 9306 that I'm going to remove, and that will separate us from the diodes that I was talking about that were kind of, I guess we'll call it upstream. And you'll notice that there's a diode missing there. And there's one patched into the back. I checked the schematic, and that is actually from the factory. You will see that from time to time. Perhaps there was a mistake on this board when they made it, and later on corrected it, but maybe this was an early run, and their way of workaround was to simply put the diode on the back instead, because if they put it in its designated spot, it would not have been correct. So looking at the schematic, this is actually correct, and there's actually would have been a jumper there, but there's a resistor put in that jumper space instead. But this is perfectly fine. This hasn't been tampered with at all. So let's take out 9306 and see if we still have voltage. If we don't have voltage, then I know that the voltage is leaking from over on this diode side that I pointed out on the schematic. And if we do have voltage, well, it rules that out, and we have to go the other direction. Okay, I've removed resistor 9305, separating the circuit for the speed control from those diodes kind of up north. So let's see what difference we made. And we still have 5 volts on the circuit, so it's not coming from that diode side.
So with this resistor removed, we still have 5 volts on this rail here, this line. So I put that resistor back into place, and we're going to start tracing over into the next board over. And looking at this, we have, you see this box here. Unfortunately, I'll scroll down and show you the rest of this circuit board. It's split between 2 pages, but that is part of an IC. That's not the whole IC. It's one of the bigger ones in there, and that's how they're represented on the schematic. Here's the rest of the board here, and this, that's all part of the same IC, and so is this, and that is of a second IC that's on that board. But let's scroll back up here, and at the moment I'm a little suspect over in this region here, these 2 transistors. Thinking maybe the transistors over here have failed and they are leaking voltage. So what I'm going to do, this resistor here goes to ground. So it'd be useless to remove that one, but this one, excuse me one second, looks like it's R9102. I'm going to remove that one, and hopefully we will find that the 5 volts is then gone, and we'll have narrowed down our problem. So now let's go give that a try.
So we had removed 9306 and still had voltage, so that means our voltage is leaking in from this board over here, because it comes through that jumper over here to pin 8 and comes through and then divides between this IC right here and resistor 9102. And then 9101, which is that one, actually shunts to ground. So now I'm going to remove 9202, and that's going to separate this IC, which actually feeds back into this board looking at the schematic. and the two transistors should be these two right here. So we're going to separate this IC from these transistors, find out if we still have voltage, and if we do have voltage, then that means the leakage is coming from this IC. If we don't have voltage, that means the leakage is coming from this side here where we have the transistors, as well as another array of resistors. Okay, as you can see, I removed 9102. So now let's do a test to see if we do or don't have 5 volts on that line. Okay, so now for the test with 9302 removed. See if we still have a voltage. And we do. So it's coming from the IC side of that board.
Well, that was a disappointment. So we still have the 5 volts there. I put this resistor back into place. And now we have to start investigating this IC. So let me show you what that is. Let's scroll down here. Let's see. That is MC14066BCP. That is a Motorola. So let's look up, find out what that is, what it does, and then figure out how to proceed from there. Here is the data sheet for that IC. Now, onsemi had taken over, bought out Motorola's division, I guess, of the semiconductors, or at least this one. But this data sheet will be the same. And this is basically, this IC is just an array of 4 switches, on-off switches. High speed, they will handle either digital or analog signals. And here's the pinout of the IC right here. It's a 14-pin IC. And you'll see where it says in 1, out 1, control 1, etc. up to 4, as well as the voltage pins. And if you go down to the block diagram, it's a little easier to understand here. So you have control, in and out. So basically, you want to think of each one of these as a light switch on your wall. So control is the little lever that you flip up or down to turn the light off or on. And in and out would be like, your hot wire coming in and then out to the light bulb. So if you look at our schematic, gotta scroll back up again. Bear with me here a second. Over here to where we are in question. We have pin 12, which is where this line, where we're getting the 5 volts coming in. It ties into this IC at pin 12. And if you look on the block diagram, pin 12 is control. It's not in or out. It's nowhere that should be bleeding out 5 volts like it is. So basically, imagine you walk into your room to turn on your light switch and you grab that lever, that control, and it sends 120 volts into your hand. That's what's happening here. So voltage is going into the light switch and coming out of the lever. So that is where our problem is. And so I'm going to confirm it. And this is what I'm going to do. I am going to go and I am just going to desolder pin 12. And I'll make sure the pin is not making any contact in the on the circuit board, and see what happens then. So let's go do that.
Okay, I'm going to just go freehand here for a second. Hopefully we keep focus. What I decided to do was just disconnect, desolder pin 12 from the pad there. And now I'll do a test and see if the voltage has gone away, and if that is the case, then that verifies that's where the leakage is coming from. And here we go with pin 12 of the IC removed, and if I still have 5 volts, I will be really confused. So we have nothing. No voltage at all. So that's where the leak's coming from. So now I'll have to see if that IC is available and order one and put it in and see what our results are. Okay, I've received my replacements, actually some Motorola new old stock for this IC. So now I'm going to remove that one, and then I'm going to replace it with a socket, and then I'll plug in the replacement IC. The old IC is now out, and now I will put a socket in its place and solder that in, and then we'll install the new IC. Okay, socket's in, everything's cleaned up. I got my new ICs here, and for this procedure I am going to don a grounding strap to protect the new IC just to be safe. And that will plug in nice and easy, I hope, into our new socket. Yeah, nice and easy. Actually having a hard time with the camera in my way here. Let's have a look, see. There we go. Looking much better. Try to keep you in view here. There we are installed. Nice, neat, clean. And I actually tested some surrounding associated components just to make sure there wasn't anything that could have possibly taken the original IC out. Everything checked out fine, so now we're going to plug it into the turntable and see what results we get now. The IC's in place, board's in place. Now I'll do a quick voltage test. I have it set on, move it over here so you can see, set it on 33. Start up the motor, and we get 5 volts. Let that finish doing its thing. Okay, we have 5 volts. Switch it over to 45. So we got 347 millivolts. But I definitely see the motor changing speed. So that 347 millivolts could be just a little bit of voltage that's in the system, or it could be just ghost voltage, which is more likely. So now let's put the platter on and see what we get. Platter's on. I have a stroboscope on there, but this is a fluorescent light, so you're not going to be able to see that. And for this initial test, I don't know if you're going to be able to see the stroboscope that's on the platter. Remember, the platter stroboscope is controlled by the system itself. It's not dependent on 60 Hertz from an incandescent bulb. So set on 33. Look, see. Pitch control's turned off. And I put a piece of masking tape on there so that we can visually see the difference. Up to 45. There you go. It's working. According to the stroboscope on the side here, it's dead on. I'll turn the pitch control on and turn the speed up, and we're changing speed pretty dramatically, actually. Turn the speed down. Takes a little bit of time to react, but yep, now we're slowing way down. Put us back up to normal. I'll switch it off. Turning the 33 knob, that's not affecting it whatsoever, so that's out of circuit. Turn it back off. Then we'll switch over to 33. And the speed is slowly coming back down to 33, and now it is stabilized and it's dead on. So now it's back on to 33. I kind of suspect, I'm not familiar with this turntable functioning normally because it was bad when I got it. But I'm kind of assuming that it takes a little bit of time to slow down to 33 just because this is a very heavy platter. So it takes a minute for the momentum to slow down on the platter itself to get back to 33. But going to 45, it goes right up to speed and locks right in. Pretty amazing. And back down to 33, slowing down, slowing down, slowing down. And I'm watching the strobe, and it kind of slows down below 33 just for a split second and then stabilizes right at 33. So it looks like that problem is fixed. The final issue I need to address on here is the damping of the tone arm. And the cueing arm lift located back here, that is damped with 300,000 weight silicone oil. You can get this through various sources online, but if you come up dry or don't want to order online, you can try any type of hobby store that handles equipment for like the high-end radio-controlled cars, because it's the same damping fluid they use in the little shock absorbers in those vehicles. So first thing you want to do is I will show you there's an adjustable height adjustment on the top side of the turntable platter. You have to unscrew that first. And this here is the tone arm nut that you will have to spin to remove it, so you can remove the shaft. And also if you need to adjust the height of the tone arm lift, this is where you do it right here. Alright, the next step is to remove the little E-clip from right here at that pivot point on the, I guess the cueing arm lever mechanism. Remove the washer. And then there's this little bushing right here. You'll remove that. And then you'll be able to lift the arm out of the way. And then you'll be able to lift the cueing arm up and out of there. And then you're going to want to clean everything off of it. And then I take a Q-tip, probably have to pull most of the cotton off, and then run it down inside the hole there and get that cleaned out also. Okay, so I'll take a small amount of my oil. So I can do it so I can show you here. And I will take the toothpick and smear it around inside there a little bit. I've already cleaned it out with the Q-tip. And then I will smear up and down the wide part of the shaft. Yeah, let's see. I'm not looking at the camera, so excuse me if I screw this shot up. So I just give it a good coating. And we just drop it back into place. Move it up and down a little bit to make sure everything's spread around. And then the most difficult part really is, before we put everything together, we want to at least start screwing the little nut that's on the underside. That actually is for adjusting your height. So I'm going to have to reach under there, kind of hold it in place while I spin this to screw it, at least get it started screwing on. All right, that's back in place. Carefully move your arm back into position here. And make sure that this pin fits between those two teeth. You will put your bushing back into place here. Washer goes on top. And very carefully, so you don't lose it, you'll put that E-clip back into place. Okay, double check that your pin is there. And now it's time to put the turntable back onto the plinth and get it ready for testing. The final issue I needed to address was the cartridge that came with the turntable. What they had originally was a completely wrong Audio-Technica cartridge mounted on the Ortofon ULM mount. This is often referred to as a sled. Now if you have this turntable and you want to put a half-inch mount cartridge on here, you have to get a new different head shell because this one pops off. I forget exactly how. And then there's a different sled that goes on there. And so I went on to eBay and got myself a actually new old stock without a stylus of a ULM 50. Now the ULM 50, 55, and 60 are all the same cartridge. It's just the stylus that is different. And what I wound up buying was actually a very cheap EVG replacement stylus for the initial tryout. And if things work out, I will upgrade to the ULM 60. So by buying the ULM cartridge, I've returned it to its original factory specs, but also I don't have to worry about azimuth alignment, cartridge angle, any of that. It's all set. All I have to do is mount this cartridge, and it's already been set by the engineers at Dual. So there's nothing to play with there. And it's just a little tricky diving this thing into the mount.
pop it up. And then make sure your stylus is seated properly and pull the arm forward. When you pull the arm forward, a little pin goes down and locks the stylus into place. So if I need to replace the stylus, I move the arm back, remove the stylus, put the new stylus on, move the arm forward, and it's done. Alright, it's time to test it out. So I figured since Dual is a distinctly German turntable, I would pick out some distinctly German vinyl. And for the 45 test, I have a choice between two different Kraftwerk 45s. Let's go with The Robots. That's a cut from the album The Man Machine. And for 33, we will go with Nina Hagen. Nina Hagen. It's an EP, not an LP, but it is recorded at 33. So that will be our test for 33. And Kraftwerk, The Robots, for 45. We're going to start with the 45 test since that's where the problem originated. I'm going to try to avoid getting flagged by YouTube for going over 15 seconds. I'll play a little bit more in the middle of the track. And now the test at 33. Alright folks, well that is it. The turntable is now fixed. So I'm going to wrap up this video just right here, right now. There is one exception. I used the wrong weight silicone oil in the queuing arm, and it's dropping a little too fast. So that is something I'm going to have to correct in the future. I think the weight I have is probably more like 90 or 100,000 weight, whereas what we need is 300,000 weight oil. And this is not going to be the last time you're going to see this turntable in a video. First video I'm going to make, hopefully within the next maybe 2 weeks, is I'm just going to go through and describe all the features on this turntable. There are a few on here that are very unique to this particular model. And then after that, down the road, it's going to wind up back on the bench. I am going to replace the 45-year-old tone arm wires with some high-quality Cartridge wires. Going to bypass everything that's in there, so we will go directly to the cartridge instead of through the contacts in this removable head shelf sled. Also, the RCA cables coming out of the back that go to the receiver, we're going to do an upgrade on those also. We were going to shoot for getting the highest quality sound we can out of the turntable. And this ULM cartridge, that's comparable to the OM10 series. If it has, actually if I go to, I'm going to upgrade the stylus on that from this cheap generic replacement stylus up to a Thacker ULM 60, which should be more comparable to in the OM series of Ortofon, the OM20. So if you're interested in seeing those videos, please hit that subscribe button. I hope you found these videos enjoyable. If you have one of these turntables, I hope you found it helpful. If you get the opportunity to get one of these turntables, by all means, they are excellent turntables and they are definitely worth repairing. So thanks for watching. I'll see you next time.